All right, 8th graders, we are starting Chapter 9. And Chapter 9 talks about extending what you already know into new material regarding perimeter, circumference, and area. So we're going to start with Section 9.1. Now, 9.1 talks about formulas you've already learned in the past and then applying them to do harder concepts. So today we're going to talk about triangles and quadrilaterals. So the first thing we're going to talk about is the area addition postulate. Now the area of a region is equal to the sum of the areas of its non-overlapping parts. So for example, you already know that a rectangle with base B and height h would have an area of base times height. You can use the area addition postulate to see that a parallelogram has the same area as a rectangle with the same base and height. So right here, as you can see, we have a parallelogram. We cut off one piece of it and bring it over here, and we've now made a rectangle. That is why they have the same formula for area. So this you already know. Here's the area of a parallelogram. The formulas that you will be using, some of them are going to be really easy, but we're going to actually put a lot of concepts of geometry and algebra within them to make them harder. So for example, number 1, find the area of a parallelogram. Well, you know that the area of a parallelogram is base times height. So the base of this parallelogram is 6, but we do not have the height. Well, the height is formed by a right triangle. Right triangle, Pythagorean theorem. H squared plus 3 squared equals 5 squared. And you should know by just looking at it that this is a Pythagorean triple of 3, 4, 5. So if you did solve this, you would get a height of 4. And that would give you an area of 24 square inches. So let's look at example B. How would you find the height of a rectangle that has a base of 5 and an area of 5x squared minus 5x? Well, the first thing I'm going to tell you is this. You should be able to figure that out pretty easily, knowing that base times height equals area. However, if I gave it to you in a proof, would you be able to tell me all of the steps? So let's just write down what we know. If you had this in a proof, we would write down A equals BH, and the reason would be area of a rectangle. We know that area is 5x squared minus 5x, and the base is 5, and the height is what we need to find. We use substitution. Then you would factor out a 5 on the left side, and we could just call that factoring out of GCF. And let me change that to just an X here. We then use the division property to divide both sides by 5. And we just found H. H is, and I'm going to use the symmetric property of equality to write it as the height, which is x squared minus x, and we put it in parentheses. So then we have a label at the end that says centimeters. So if we had x squared minus x centimeters, you're only putting the label with the x. So whenever you have a label with an expression with more than one term, put parentheses around that term. So the height of this rectangle is x squared minus x centimeters. In C, we want to find the perimeter of a rectangle in which the area is 12x feet squared. So using our formula, area equals base times height. I just plug in my values. That gives me 12x equals 6b. So I divide both sides by 6. Therefore, the base is 2x. If I found the perimeter would be 4x plus 12 feet. Now, to derive our formula for the area of a triangle and a trapezoid, a lot of you just know what the formulas are, but do you know how you get them from area of a parallelogram? Let's look at this. If we have a parallelogram, we would take base times height. If we made a triangle out of it, it'd be half of base times height. The same thing is true here. If you had a parallelogram, and here the base would be base 1 plus base 2. to give you the entire base. So base 1 plus base 2 times the height is the area of this parallelogram. However, if we take half of it, that's how we get our formula of 1/2 of the sum of the bases multiplied by the height. You already know the area of a trapezoid, the formula for the area of a trapezoid and a triangle. I'm not going to go over it, but here they are. We're going to skip example 2a and go right to 2b. Just because 2a is easy, you already know how to do it. We want to find the base of the triangle when the area is x squared. Well, if we use our formula, 1/2 base times height, we first plug in the area as x squared. We plug in the base as b, and the height, which is x. Well, the first thing I would do is I would multiply both sides by 2 and get 2x squared equals xb. I divide both sides by x, and so the base would be 2x. And we put on our label, and the base will be 2x inches. In part C, we want to find one of the bases of the trapezoid, in this case, base sub 2. So 1/2 multiplied by the sum of our bases, multiplied by the height, and if we plug everything in, that would give us 8 equals 1/2 base sub 2 plus 3 multiplied by 2. This should be fairly easy here. 1/2 of 2 is just 1. I subtract 3 on both sides, and my base is 5 feet. Next, we're going to talk about the area of a rhombus or a kite. Now, a kite or a rhombus with diagonals of d sub 1 and d sub 2 can be divided into two congruent triangles. And it shows you how here, for example, you can take the area of each triangle, multiply them together to give you this. So it derives us the formula to find the area of a rhombus and a kite. So here's the formula we're going to use. When we have the diagonals, d sub 1 and d sub 2, the area is going to be multiplying those together and taking 1/2. So 1/2 of the diagonals multiplied together. In example number 3, in A, we're going to find one of the diagonals of a kite when the other diagonal is 16 centimeters and the area is 48. So A equals the diagonals multiplied together, multiplied by 1/2. If we plug this all in, we would get the area, which is 48, equals 1/2 multiplied by 16, multiplied by the other diagonal. You can solve this on your own, but you would get a diagonal of 6 centimeters. All right, example B. Find the area of a rhombus. Well, the area of the rhombus would be multiplying the diagonals together and multiplying by 1/2. In this case, we have two binomials that we are going to multiply together. The first thing I'm going to do is, rather than actually multiplying these together, I'm just going to distribute the half. And I'm going to get 3x plus 2. Now, you don't have to multiply the half right away. You could FOIL first. And then I'm going to FOIL. That would give me 30x squared plus 30x plus 20x plus 20, which would give me 30x squared, combine like terms, plus 50x, plus 20 squared inches. Now in C, we're going to find the area of the kite. So we're going to multiply the diagonals and take 1/2. We have a problem, though. We don't have everything. So the first thing we have to do is we have to use Pythagorean theorem. These are right angles. The diagonals are perpendicular. So if we used Pythagorean theorem, we could do x squared plus 81 equals 41 squared, which is 1681. X squared equals 1600, and x would equal 40. So we know x is 40. Now we need to use Pythagorean theorem again. So this would be y squared plus 81 equals 225, which will give us y squared equals 144. Take the square root, and we get y is 12. So now if we multiply the diagonals together, that would give me 18 multiplied by 52, and that would give me an area of 468 square feet. In example 4, we have a tangram, and we need to use the grid to find the perimeter and the area of the red square. Right there. So we know that the side length is 4 centimeters, so each box represents 1. So I'm going to draw the red square right here. So we're going to pretend that's a red square. Actually, let me change it to my red marker. So there's my red square. Horrible picture, but there it is. We know that each of these are 1. So we know this is a 1, 1, root 2 triangle. Now you could also use Pythagorean theorem to prove it's root 2. So we know each side is root 2. That means the perimeter, if we added up root 2 4 times, would give me 4 root 2 centimeters. But now we need to find the area. Well, we can just multiply the diagonals. The easiest way is the diagonals would each be 2. So we just plug it in as 1/2 of 2 multiplied by 2, which would give me an area of 2 squared centimeters. In this section, you do have formulas for area, but there are no new vocab words that you need to write down.